in our this 58th class of dairy and food process and products technology, we should cover also some packaging, because processing and other things we have already discussed a lot, and packaging, storage, this we have discussed, but may not be so so elaborately. So let us also look into the packaging of food materials, typically with respect to dairy and food materials both, right? Because liquid and solid, in that liquid milk we had shown you more or less elaborately, liquid milk packaging and distribution, all these we have discussed elaborately. But since it is also a part of the food that is solid, we have also covered a little of solid. So this both liquid and solid, we should take care of the packaging, right? So first you see, nowadays those which you get from the market, like your chips or this and that, so all of them you must have seen that they are filled with some gases, right? Had it been only chips, the volume would have required very little, but your material is only this much, but the packet is so big, right? So that is primarily because the environment around the product, you got it changed. Why? Definitely to give its shelf life much more than what it would have been otherwise. Depending on the product, depending on how you are preparing, depending on how much fat content or consistency or constituents of the product, the packaging type, packaging variety, everything changes. Because nowadays you have seen the market is primarily dominated by the packaging, and the better the packaging, the attractive the packaging inside product, because you are not able to see what is there inside unless you spend money, take and then test. You don't know whether that will suit you, you would like that, or etc. etc. So packaging is a primary or important step for your product, both storing as well as selling. Right? It is also storing minded, because you might have seen that in the packets it is written best before 6 months, or some packets best before 1 year, or in some packets maybe best before 3 months, etc. Or directly it is given date of manufacture such and date of expiry such, right? And that time could be 1 month or even more, depending on obviously the product you are handling or you are packing. So for that, different types of packaging will come across, and also in this regard we would like to highlight or discuss a little about the storage through that. Right, we have already discussed a lot about the cold storage, that the ice cream and many other frozen products, they are stored in the cold store, and we have discussed a lot in the purview of the course, right? So it is not that whatever we have discussed, that's the end of the entire thing. No, within the purview of the course, whatever cold store we have discussed, because cold store when you do, you have to also design. It is not that you make a room and you go and dump your material. The primary reason is that your purpose is to supply, to support with a definite temperature. So that definite temperature and constant, definite and a constant temperature, it should not fluctuate. That to make it, you have to design, and that cold storage design, not only on thermal, that is on refrigeration part, but also civil part is also there, because that too, if it is a sub-zero, one type, if it is above zero, another type. In all the cases, there is also some vapor barrier, because your insulating material, that should not be affected by moisture. So in the room, like in this room, moisture is there according to the relative humidity of this room, and that moisture, if that is cooled and if that is getting deposited on the insulating material, then the performance of the insulating material will go down. So to avoid that, civil part is also and not only that, but also for the structural strength, civil part is also equally important. So refrigeration, civil, mechanical, then our food, all put together, we will design a cold store either above zero or sub-zero. So both the cases, obviously the design consideration parameters will be different, and unfortunately this is not within the purview of this course, because where to start and where to end, right? So I have been giving you these inputs, and then you think, you thought, give a thought, and then you design, or you know, you develop yourself, so that you can also become a one good designer. But that course is different. I don't know whether in future I will be able to float such like a cooling technology in agriculture and food engineering. Let us hope we can, and if we can, then at that time all these will come into, right? Obviously, we will not repeat this whatever has been, and there is always a little overlapping of the subject, of the topic, of the understanding, that is unavoidable, right? But as far as practicable, we will try to do that. However, coming back to the cold store, that when you are designing, you have also to look into that, like in this room, suppose if it is a cold store, and suppose this is a ice cream cold store, that is sub-zero, -20, then and you imagine that all ice creams are being stacked one over other throughout the room, and then that should be cooled, because from the evaporator the cold air has to circulate. So there has to be a forced circulation through fan, so that uniform temperature throughout is maintained, because sub-zero -20, if it is going up, so -10, as such you will get this water not completely transformed into ice, completely transformed into water. That part will not be, but definitely some temporary and localized this transformation will go up, which we discussed about the freeze and thaw. That thing will appear or happen, which is never desirable for the product. So you have to be cautious about that. Circulation of air, stacking density, right? Like at home, if you dump, say, your garments one over other, right? The lowest one is obviously totally gone, and that way you are not able to keep your garments in good condition for a long time, right? So here also, if you are dumping absolutely with full volume of the room, then there will be very difficult for the air to circulate and the temperature to be maintained. So these things that come in, and you have to look into in detail, right? So let us go now to the packaging, right? So if we go into the packaging, the first thing is coming as vacuum packaging, right? Vacuum packaging. And in this vacuum packaging, what you do, you take the product in a container, whatever be the container, that could be a plastic container. Nowadays, plastic has taken up, I mean, though it should not be, because some days will come, because these plastics are not recyclable as well, they are not biodegradable. So the soil of the earth is getting really affected badly throughout the world. So maybe some substitute alternative of the plastics are supposed to come, and someday they will be developed and will replace these present status. But as of now, those kind of plastics, if they are there, so what is happening, that inside whatever content is there, but the air from the inside is sucked off, right? That sucking is done by the vacuum pump, right? To this effect, let me tell you, there are primarily two types of vacuum pumps which are working. One is up to 10 to the minus 3 torr, that is normal household or laboratory or commercial, where your vacuum level is up to 10 to the minus 3 torr. But, so I hope you understand torr, right? 1 torr is 1 millimeter, 1 torr is, yes, 1 millimeter of mercury. So 1 torr, yes. So that you please check. And that 10 to the minus 3 torr you can do with normal rotary vacuum pump. But if you need more than that, of course for this food application you don't need, that is good enough. But if you need, since it has come, there are some diffusion pumps also, and with the diffusion pump you can go up to 10 to the power minus 6 millimeter of mercury, right? 10 to the power minus 6 torr, you can go to that level, and this high vacuum is in many cases required for leak detection and others, right? So you have a pipeline, and you have very costly gases going through that pipeline. So if there is some leak, you are losing a huge amount of that gases which are costly. So that is not, and as such, like ammonia, you can detect its leak because of its odor, but in many cases there is no, like freon, there is no chance. You cannot do that. You cannot feel that a freon is getting leaked because there is no flavor, no odor. There is no odor, and since it is odorless, then your leak is very difficult to recognize or identify. For that, in many cases, those diffusion pumps are used, right? It's like we have in our cryogenics center one called diffusion pump 10⁻⁶, which can detect that leak of helium. Helium gas is very costly. So earlier helium used to be produced there. So that helium gas leak detection is done by this vacuum or diffusion pump, right? Okay, we have deviated a little. Let us come back again to vacuum packaging, right? So from this we see that vacuum packaging is another way to increase the shelf life of the product, and here the product is placed in an airtight pack. The air is sucked out and package is sealed. By removing air from around the product, the levels of oxygen in the packaging are reduced, impeding the ability of oxygen breathing microorganisms to grow and spoil the product. The lack of oxygen also reduces the amount of spoilage due to oxidation, the process that causes apple, banana to brown, or for example, right? So, lot of things we have said. Number one, you are removing air, thereby air contains 21% oxygen and 79% nitrogen by and large, we can tell. So, out of that 21%, whatever damage is being done, that is through oxygen, not the nitrogen. So, oxygen, when you are removing air, you are also removing oxygen. So, when you are sucking off that air, oxygen is depleting, and the moment oxygen getting depleted, there are organisms which we have said earlier that it could be aerobic or it could be anaerobic, right? There is facultative and many others like that can grow both in presence or in absence. So, we are not just going into those, because this is not the microbiology class. So, this aerobic organisms, they require oxygen for their sustenance as well as growth and activity. So, when you have removed this oxygen, then you are keeping aside or you are throwing those organisms out, because they will not be able to survive, right. That is one step which you have taken for the long term storage of the material you have packed. So, your packet is now, there is no oxygen, right, or if it cannot be made to no oxygen, it could be at least very little oxygen, which is not sufficient for the organisms to survive. That is number one. Number two, that as we have said earlier also, that when you cut apple or potato or things like that, then what is happening? They are getting brown, right. So, that browning is because of the enzyme in presence of oxygen or oxidative or enzymatic, both could be, right. So when you have removed this oxygen, so oxidative browning you are, or oxidative changes, oxidative or oxidation you are removing the chance. So you are protecting your food material by two ways, right? So this is one way of maintaining a long time or packaging material with vacuum. You are extending the life of the product, right? So a certain amount of oxygen will remain, as we said that it may not be possible to uh, clean or clear all the oxygen present. That is why a certain amount of oxygen will remain. However, because it is not possible to create a total vacuum, okay, air contains around 21% oxygen at around atmospheric pressure, that is 100,000 millibar. As the air is withdrawn, as the air is withdrawn during the vacuum packaging process, the pressure inside the package is reduced. If, for example, the pressure is reduced to 100 millibar, an equivalent of around 2.1% oxygen will remain. If it is reduced to 10 millibar, there will be an equivalent of 0.21% of oxygen present. So we are not able to remove entire oxygen, right? So depending on how close, how much you are doing your vacuum, right? We gave example that if it is 1000 millibar, if it is 21%, then if you make 100 millibar, then you are bringing equivalent to 2.1% of oxygen. If you are making 10 millibar, that is vacuum level, to that the pressure is 10 millibar, then you are making the oxygen equivalent to 0.21%. If you are making 1 millibar, then you are making equivalent to 0.021%, right? So you are not making zero. Making zero is very difficult. So that depends on to what extent you are reducing your pressure, that is you are making vacuum. So that will dictate how much you have oxygen present in the container. However, the smaller the better it is, right? Is vacuum packaging is more effective than modified atmosphere packaging? This is a question which I am throwing to you. The answer should be that, as with most things, it is a case of horses for courses. This is said that race horse performs best on a race course to which it is specifically suited, right? It depends on the product being packaged. So the answer to this is that we have said horses for courses, that is racecourse performs, the racecourse horse performs best on a race course to which it is specially suited, right? Definitely one horse in a one race course, from there if you take to another where it was there, may not perform to that, right? So depending on which one what you are doing, that will dictate whether vacuum packaging is better or some other packaging is better, right? So there is no comparison, that is not absolute. Also comparison, it comes always, because comparison will come when when your product with vis-a-vis the cost involvement that comes in. So if the cost is too big, definitely even though the quality of the product will be better, you will not go for it. Right? So because ultimately you have to see whether the consumer will go for it, that is they will buy or not. Otherwise you would not try to do such activities, right? Then flushing with inert gas, right? This is done in most of the cases, as I gave the example of the chips, potato chips, that flushing with your inert gases, that is one of the best packaging, right? And inert gas, the most available inert gas is the nitrogen gas, right? Because that is the most suitable one, the nitrogen, which is plenty available, price is not so high. So what happens? The inside of the packaging material, the air is purged. This is called purging. Air is purged off by nitrogen. And as I said, nitrogen you may have, depending on the purity, it is 98% pure, 2% oxygen, 99% pure, 1% oxygen, 99.99% pure, 0.01% oxygen, the one which you need for your laboratory purposes, typically for HPLC or GC or things like that instruments, there you need 99.9999% of purity of the gas, right. So their oxygen is as minimum, but price is also very high. So you have to compromise between the price, availability and your utility. So in that case, this nitrogen which is available in the market, that can be used very effectively, purging the air, and you can produce an inert atmosphere, right. So let us look into that flushing with inert gas, that benefits what? Nitrogen is an inert gas and is used as a filler gas because of its insolubility in water. Nitrogen on its own can delay oxidative rancidity in low water activity products. Flushing of potato crisp with nitrogen is said to increase the shelf life from about 60 days without nitrogen to about 120 days with nitrogen. Another advantage of nitrogen flushing is that uniform pillow packs are produced. So pillow packs kind, which I said that it is bulged. So that bulging is also protecting your food material. Those which are crispy, like see if it gets some kind of impact, so that will break that, which may not be sold, or the buyer may not like it, right. So that will help, it will protect, it will give a pillow kind of protection, right, which prevents damage of the fragile snack products during handling and distribution. The use of the flushing has brought improvements in the barrier properties of packaging materials and in seal performance. The use of this technique has been shown to double or triple the shelf life of these products, right. So flushing with nitrogen is definitely beneficial, not only from the point of view of the shelf life, but also from the point of view of the protecting the product from such kind of impact, or the fragility of the product can be protected. So we today discuss these two packaging, that one is vacuum and another is the flushing, right. So in the next class we will try to bring some other, and this is of course not only for dairy products but also for any solid products, right. Definitely not the liquid products. Normally liquid milk is not packed under neither vacuum nor with nitrogen, right. So their game plan is altogether different. Okay. So with this we finish today's class because time is up. Thank you.